Section 2.3, example 17, selecting the best method. For each of the following problems, select the best method to find the volume of the solid of the revolution generated by revolving the given region around the x-axis, and set up the integral to find the volume. Do not evaluate the integral, the region. Okay, so part A, the region bounded by the graphs of y equals x and y equals 2 minus x. So here we have these two graphs here. I really like it, but what we would have to do if we were integrating just naturally, we would have to integrate first from 0 to 1, finding that region, rotating it about the x-axis and finding that volume, then integrating this side over here to find the volume of this area. So instead of that, why don't we just turn it on its side and integrate with respect to y? So y, revolving it around the x-axis. And in this case, we could use our cylindrical method because we're revolving around the x-axis. And in terms of y, which is kind of what they want. And we're integrating from 0 to 1. So we could do that. So integrating from, in terms of y, from 0 to 1. And here we're looking at our tallest point. So we're looking at this graph minus this graph. But we're kind of getting ahead of ourselves. We have 2 pi x. Actually, we're in terms of y, 2 pi y. And we're multiplying our top minus the bottom. So here, let's get in terms of y. This would be x equals 2 minus y. So that's our top function. So x equals our 2 minus y minus the other function, because on this entire interval here, from here to here, this one's on top, this one's on bottom. So y is equal to x. So here we're just looking at y. And now that we have that, still integrating from 0 to 1, we could pull the 2 pi out. We have y times 2 minus 2y dy, or 2 pi 0 to 1 negative 2y squared plus 2y dy. And there we go. Setting up the problem. We could have technically just stopped right here, but we're overachievers. We want to kind of simplify it without having to solve it first. But there's that first part. Let's take a look at part B. What could we use to be lazy for part B? So still revolving around the x-axis. I kind of like the simplicity of just our disk method. So looking at the radius of each individual part here. So we could have done the disk method over here too, but remember disk method, we would have to find from here to here, and then after another integral from here to here. This one is all one graph, so we just need one integral. So our disk method is breaking up the entire space into like an infinite amount of disk, where we're adding a bunch of different circles there with radius of however tall our function is at that point. So volume is going to be equal to the area. So integrating from 0 to 4, it looks like. So from 0 to 4. And integrating. All right, so for each circle, it's pi r squared. So we have pi r function squared for x minus x squared squared dx. And honestly, I kind of got lazy. In order to solve it, we would expand it, and it really isn't that bad of a graph here. Like, we don't have any trig functions that we're integrating. We don't have any hyperbolic functions, nothing too crazy. You don't even have to do any of the other stuff. You just leave it as is like this. There we go. Just because they don't want us to evaluate, but that's it. If you have any questions, please feel free to ask. Otherwise, bye.